Hey everybody, thanks for stopping by my channel. I appreciate the fact that you're going to spend some time with me. I know time is very valuable. Today's video is a continuation. I'm going to show the building of the adapters for the Milwaukee Porta Band. This adapter keeps the stock handle in place when you build a stand that matches my stand. The stand works out fantastic, and had some guys build. I've got a couple more requests for the handles. The other couple items on here, I'm going to have some video on some lenses. I got some new glass for the grinder, and also got a new optical magnifier for the radius dresser for my surface grinder. And then a couple of tips that I've picked up off the web. Great website. One will be for aligning the tailstock on the lathe, and the other one is for aligning the head on the mill. Both of them are quick tips for getting both units very close. So I hope you enjoy, and again, thanks for stopping by, and appreciate the visit. Okay, well, back, and we're going to continue on making the adapters for the Milwaukee Sawzall. So, as you know, last week I showed you on Screwy Tuesday that I had Mr. Bozo paid me a visit, and then I ended up completing the bar. So now I need to go ahead and cut off all the pieces and size the pieces in the width. And then after that we'll drill all the center holes in there. And then honestly, I can't remember how I did this radius last time for the life of me. It's nice and clean. I don't think I sanded it. I know I wouldn't have sanded. I think I built 8 or 9 of them last time. And it turns out it's a perfect 3/4 radius there. So we'll set it up. My plan is to set it up on the rotary table, make a fixture to hold it, and just buzz off the tops. And then I got to figure out what I did here too. I don't remember. I may have done that with the belt sander. Can't remember, but we'll cross that bridge when we get to it. And then turn and drill and tap the handle hole. So a couple little procedures here. So right now is just start sectioning off parts. So set the scriber here to the size of the part, and then in the mill squared off the end, and then just come over here and give it a quick scribe, and that gives me my my cutoff. Give it a little extra, and then come back and clean it back up in the mill. Put a stop in place and get them all the same size. So, since my setup, that's hot still. So what I'm doing here, ouch, is holding it in a vise like that on the little tit that's sticking out, and that way I can make my cut. Then back over to the mill, straighten this back up in the mill, then mark it again and cut it again. So what I have here is just a stop setup. Gives me the right dimension. Put the milled side against the stop, and then cleaning off the sawed side to bring the part to size. Working real good. Simple as that. We'll continue on. Well, a little side light here. I had to order a new lens for the front of the dresser, And I knew that when I purchased it. I don't know if you can see it in here. The original lens was cracked, and then you can see where there's abrasion on the lens where somebody had actually run this dresser backwards. You can even see the marks here on the dresser. Anyway, kind of a little humorous. I knew I had to buy it, and it was $50 for the lens, and they charged me $17.66 for freight. This lens is about, you can see, it's no bigger than my thumb, at the end of my thumb, and it weighs about, it weighs less than a quarter. Anyway, well, for my $17, they didn't spare any expense on the box. So this it's in here. There's the new lens packaged, and it's in a box that's 10 inches by 6 inches, quarter-inch thick. So it must be the box they ship other things in, and that's the way they do it. So expensive on the shipping, but I got the part, and we'll put that back in, and it'll be serviceable. While I'm talking about new lenses, let me hand carry over here. I got the new lenses for my grinder. You can see there was the glass that was in it. It's laminated, 2 1/8-inch pieces, and there's the new lens in place. So that worked out nice. Simple fix. I called my mirror and shower door guy. He had the glass in stock and cut them for me. So got a couple clear views working now, and we'll continue on. And here's somebody coming in from his breakfast. It's in the morning here. Okay, go back to my tool build there. Well, I thought I'd test this little trick, I guess, that I saw on a website. Frank Ford is the fella, and it's frets.com. He does a lot of machining things on there in the past. So I've got a piece of 1-inch aluminum bar in here, so I'm going to turn it, center drill it, and then part it off, and then we'll come back. So I'm going to jump to the test portion of this, and then I'll go back and explain what I just did. But with the, if I move the dial if I move this back, I'm about, oh, what am I? I can't do that in a second. I'll have to back up. But right now, if I take my fingernail and run it on this shaft here, it's 2 separate pieces held in place by a center. I get no click on my fingernail. So, but if I go to the back side, I get a click. So it's showing me that my tailstock is off in this direction. Excuse me, in this direction by just a hair. And when I moved this direction with the dial indicator, I get a little bit of movement, and I can feel it right there with my fingernail that it's a little bit low. Not much I can do with my tailstock in that regard. But let me pull this out. Let's see. Oh, that was a nice one, Chuck. All right, got to move you around here for a second. All right, sorry for the jumble. Trying to get everything in here. But what I created, yeah, what a mess. What a mess. Okay, this isn't working. Trying to do this with the camera. But what I have is a center there. Pull this out. So we turned the shaft and then went ahead and center drilled the shaft, then parted it and cleaned up the material, so deburred it, and then put it on the center and bring the center forward to see if the part centers back up on here. And as I said, right now it appears that my tailstock is a little bit this direction towards me. So for shits and giggles now, we'll go ahead and pull this apart and go ahead and indicate and see if I come up with the same reading. Okay, second thought before I did anything. So I went ahead and adjusted the tailstock so that I can't feel any variance here between the two pieces on both sides. So I actually moved the tailstock away from me that little bit. So right now it's showing that those are both lining to touch. So now I'll go ahead and check it. Well, I have to tell you, I really am enjoying this new tool that Andrew Padaka, my friend, sent to me, the multi-anvil mic. So the reason I'm using it here too is I'm setting up, so I have the distance to center, and this side will go on the fixed jaw side of my mill, and my DRO is already set up, so it'll put it right on center in the mill, and I'll have this in a drill chuck and just come down, set it right in the mill. I'll show you, but loving this new tool. So my dimension to center from back of jaw is 5/15/5, and you might be able to see the DRO, and that's what it's set at, 5/15/5, and the part just fits perfect right there. So that centers up my my quill, and just tighten the part down, and I'm ready to start drilling all the parts. I'll put a stop in there and start drilling. So got the stop set, and you can see the gauge pin goes nice in and out, and we'll put a part in there. The stop is set, and get a part, and we'll get to drilling. Main thing is to remember which way to orient the part. With aluminum tap on it. Makes a little racket as it goes through that bottom area. Works nice though. A little cleanup, and now go ahead and start the radius. So to line up my rotary table, it's got a 3/4 inch hole, so just put a 3/4 inch end mill upside down and line her up. So got that perfect, can lock off the table, and then I have my pallet has a 3/4 inch spud that lines up the pallet, and then it goes down on the T-bolts. So I'll go ahead and get this guy in place, and then it's got a center spud that I can go ahead and bolt into. So just lock the table, stayed in place, and then zero out the DRO, so that I can return back to this after I make any moves. So the pallet on my rotary table is square. So you can see right here I've indicated the edge of the table to be in line with the mill table. And my thought is next is to drill and bolt this plate down and get it onto the pallet, and then I'll have to move over, since the hole in this is not in center. I'll get this piece on center so I have some sort of reference, and then I'll move and cut a what I call a dado, right? A recess to accept this part, to put the part on center on the table. And then I can go ahead and turn the table and cut the outside radius on it. That's my thinking on how to do this. So we'll progress on. Okay, so I gone ahead and cut center of the block, drilled a clearance hole, tight clearance hole for a 1/4 inch Allen head cap screw, and then went ahead and counterbored for the cap screw to go down below. So we'll get it set up here on the plate now. Okay, the block is fastened down to the table now, and it's parallel to this edge of the table. So I'm going to put an extra clamp on it so I know it won't move, and then I'll locate and cut the slot that this part will sit in, which will offset it correctly. So here I'm just finishing the slot for the part. And we'll see if my math is correct in offsetting the part. Did the work over there on the whiteboard. So I want to put a stop here so I can just repeat and move the parts in and out quick. And I was thinking about drilling and putting a pin in or something off of this, and finally came up, I think the best idea is just got a cut-off screw that I had laying there on the bench, and I mixed up some epoxy, and I'm just going to epoxy that into place in the fixture there. And I think that'll work well to hold the stop. It's just going to be bumping it nice and easy, and that should work well. So we'll get that glued in there, and that'll be my my fix for a stop. Of course, I didn't want to touch the end of the bolt in the epoxy. Nice job there, Chuck. Let's get it all the way up in there. There we go. Okay, I think that'll work good. Just mix it there on some blue tape right here real quick, and I think that'll work out well. Alright, we'll bring you back. Well, you can see I've made one cut already, and got the new part up against the stop I put in there, clamped down, and we can go ahead and make another cut. Okay, only about 9 more to go. Now, the original part, I mentioned that I had knocked off the other corners and couldn't remember how I did it. Well, on this one, again, I've knocked off the other corners, and I just basically turned it around in the jig, and I'm cutting the other side off. Just a little trim. It softens the corner, and so you don't end up with a sharp corner there. So, rinse and repeat and knock all those off. Okay, those are all done, so now a little flat on the top and then drill and tap. So we'll clean up the mill and we'll get set up to do that. Any of the new guys out there that happen to be watching my channel, if you haven't made yourself a set of these, I tell you, they're great. They're so handy. I saw them on Tom's Techniques. He gave instructions how to build them. They're out of aluminum, and they're way handy compared to putting the little step blocks behind the mill hold downs. Anyway, just a little idea. All right, we'll be back. So here I'm just cutting a flat on top of the part. I'll get you hooked up so I can't move the vise. Yeah, maybe I can. Sorry for the wiggle there. But just getting it flat so where the cross bolt goes through. Okay, got it set up here, and I'm just drilling the clearance holes for the 1/4 bolt. Well, this is kind of the fun part. I get to use my tapping head. Having fun with this. Well, they're done. Just cleanup and deburring is the end of this. Hope you enjoyed watching it. Well, I put the coaxial gauge in the chuck here, and I've got it extended into the bore on the tailstock, and it's proved out that this little device works pretty good for getting it lined up. Right now I'm at about the 3 o'clock position with the probe, and I have it on 0, and right there you can see it's off 0, almost 4/10. This is a 5/10 indicator, and that's at the 6 o'clock position. And if I come back up to 0, I'm just approaching the almost there. Can't see behind the camera. Yeah, there it's on 0, and I'm at the 9 o'clock position. And if I go all the way to the 12, yeah, right about there. And you can see I'm about 4/10 the other direction, which is basically what my indicator showed when I had it in the tool post for the up and down on it, and I've got it on center now. So guys might try making one of these. Again, the website is frets.com. His machining tips. He's got quite a few in there, and I'd read this one a long time ago. He's got photos and stuff, and it works really nice. All right. Well, while we're talking about frets.com and Frank Ford's tips, this is another one. This is a disc with a 3/4 inch stem on it. I'd like to say that I made it, but I didn't. I picked it up somewhere along the line. But if you take your head out of tram tilt it or rotate it and you want to bring it back, this is a quick way to get it really close. You put it up in the mill and you bring it down to the back of your vise, and then with a feeler gauge you can check it. So this is a 1.5 thou, and it won't go under anywhere, but if it'll show you real quick which way the head's out and how to get it back in alignment. I've used it in the past and it's worked out really well for me. So I thought I'd show that to you. So you noticed I wrote on it for myself. I'll come out after a couple of cocktails and throw it in the lathe and make something out of it. So handy tool, make one, or if you can come across something like that.